Hello guys, welcome to my video on mass concrete. Mass concrete is a type of concrete that is used in large structures such as dams, foundations and bridges. Mass concrete is a complex and challenging material that requires careful planning, design and execution. By understanding its properties and challenges and implementing best practices, we can ensure the success of mass concrete projects and build structures that are strong, durable, and sustainable. So, before we proceed further, you are requested, if you are new to my channel, please subscribe to it and don't forget to press the bell icon to get video updates. So, let's get started. First of all, let us define what is mass concrete. Generally, mass concrete is defined as a large volume of concrete that is placed in single pour, often exceeding the several cubic meters. It is typically used in structures that require a high level of strength, durability, and thermal stability. Mass concrete is typically defined by its volume, cement content, and heat of hydration. Let us define it by volume. The American Concrete Institute (ACI) defines mass concrete as any volume of concrete with dimensions large enough to require that measures be taken to cope with generation of heat and attendant volume change to minimize cracking. It's mean that mass concrete is that type of concrete which generates large amount of heat, which is called as heat of hydration. What is heat of hydration? I have made a complete and detailed video about heat of hydration of cement, the link of which is given in the description. Must watch that video, or simply you can click the I button to clear your concepts about heat of hydration. Generally, mass concrete structures have minimum dimensions of 3 feet or 0.9 meters or more. It's mean that any structures whose least dimension is 3 meters or more than 3 meters will be considered as a large structure, and concrete poured in that structure will be called as mass concrete, as its heat of hydration will be considerable. Now, if we define mass concrete in terms of quantity of cement, it is defined as high cement content can lead to increased heat of hydration, which can cause thermal cracking. Mass concrete often has a high cement content, typically exceeding 400 kgs per cubic meters or 25 lbs per cubic foot. If we define in terms of heat of hydration, it states that mass concrete generates significant heat during hydration, which can cause thermal cracking. The temperature rise in mass concrete can exceed 50 degrees centigrades or 90 Fahrenheit above ambient temperature. As you can see over here in this picture, this is the graph showing heat of evaluation for a typical or normal concrete. But in case of mass concrete, heat of hydration graph goes somewhat like this. Okay, such type of concrete whose temperature rises above 50 degrees centigrade will be considered as mass concrete. Now there are some additional factors. By considering these factors, engineers can determine whether a concrete structure qualifies as mass concrete and take necessary measures to mitigate potential issues. Other factors that can influence the classification of mass concrete may include type of cement used, aggregate size and type, ambient temperature, cooling or heating measures employed. Now, let us discuss the examples of mass concrete. So, first one is dams. The second one is large foundations, bridge and piers, high-rise foundations. As in the start, I have defined mass concrete in terms of volume, which means that if the least dimension of any structure is greater than 3 feet, it will be considered as mass concrete. And the structure you are seeing over here are exceptionally very large, so the concrete poured in these structures will automatically be considered as mass concrete. Now let us discuss the characteristics of mass concrete. There are some key characteristics of mass concrete which may include large volume of concrete placed in a single pour, high temperature rise due to hydration of cement, risk of thermal cracking, high strength and durability requirements. What are the challenges in mass concrete? Mass concrete poses several challenges including thermal cracking. The high temperature rise during hydration can cause thermal cracking, which can compromise the structure's integrity. The second challenge is temperature control. Controlling the temperature of mass concrete is crucial to prevent thermal cracking and ensure the structure's durability. The second challenge is mixed design. The mixed design of mass concrete requires careful consideration of cement content, aggregate size, and admixtures. Now, let us discuss the few considerations which should be in your mind while designing a mixed design for mass concrete. So, the first one is cement content. Minimizing cement content can help reduce the temperature rise and risk of thermal cracking. The second consideration is aggregate size. Using larger aggregate sizes can help reduce the cement content and improve the concrete's thermal stability. The third consideration is admixtures. Admixtures can be used to improve the workability, strength, and durability of mass concrete. The most challenging thing for mass concrete is to control temperature. To control the temperature of mass concrete, several measures can be taken, including pre-cooling. Pre-cooling the concrete ingredients can help reduce the temperature rise during hydration. There are few methods which are used to pre-cool the ingredients of concrete like cement, aggregate and water, etc. Insulating. By insulating you can control the temperature. Insulating the concrete can help reduce the temperature gradient and risk of thermal cracking. The third measure to control the temperature of mass concrete is proper curing, and proper curing is essential to ensure the concrete's durability and strength. Now, what are the best practices for mass concrete? Some best practices for working with mass concrete may include careful planning. Careful planning and design are essential to ensure the success of mass concrete projects. The second best practice could be temperature monitoring. Monitoring the temperature of mass concrete is crucial to prevent thermal cracking and ensure the structure's durability. Last but not the least, the best practice which can be adopted for mass concrete is quality control. Implementing strict quality control measures can help ensure the quality and durability of mass concrete. So guys, that's all for today. For similar videos and the topics related to civil engineering, you are requested to please subscribe to the channel and don't forget to press the bell icon to get video updates. That's all for today.